Now I will push this model to the ProtaSteel, and it's been created in ProtaStructure. So for this purpose, I'm going to select Steel Design drop-down menu and select the Load ProtaSteel. All these members are imported to the ProtaSteel environment. First, I would like to show our macros. So more than 90% of the connections can be done with these macros. But however, time to time, we need to create our own custom connections. So today, I would like to show a hunch connection for this point. And we will transform this connection to the user-defined macro. And the last one will be the circular base plate to this position, and we will add anchors to that plate. First of all, I would like to hide some unnecessary components, some unnecessary members, which is given in this view. So let's double click to the empty space and select the filter option. In the profile tab, I can unmark, for example, purlin girth braces here and select the OK button. All these members will be hidden in the selected view. You can also play with the view range with the minimum and maximum values. Okay, now I would like to talk about a little bit the member heights. So as you see, the beam flange is located a little bit more upper than the column height. So I need to extend the column height to create a proper connection. For this purpose, I'm going to select the member and change the end offset as, for example, 50 millimeter. Of course, we can copy this adjustment to the rest of the colors. Sorry. Okay. So, of course, we can copy this adjustment here. So I'm going to select these members here, which will be copied. Okay. You can press to the control button for multi-selection. And I'm going to select match properties command here. And we can select the adjusted member to copy this adjustment. As you see, all columns height has been increased with this value. So I would like to isolate these two members. So for this purpose, you can just right click and click to the show only selected button. And for the rotational center, we can determine the rotational center of this column to turn around this in this view. For this, we can select to the F9 in our keyboard and select the pivot point so we can quickly turn around this point and create our own design. Now I would like to create a plate, end plate actually. So to do this, I need to create section on the surface of the flange. So let's create a section by 2 points on the surface of the flange. Okay. Now, as you see, the coordinates are stayed in the global coordinate system. So I would like to move this coordinate system to my view plane. For this purpose, select the view plane command here. Okay. It's important, otherwise you will not able to insert your plates properly. So first method to insert a plate is dx, dy, and dz. So I will show how we do this. First, we can select the intersection of those 2 points. And for the third point, I will press the enter button, and I will specify the distance. For example, dy minus 700 millimeter, and press the enter button. Again, I will do the similar, enter dx minus 150 millimeter, and press the enter button. And I will select the first point. As you see in the 3D view, the plate has been generated here. So you can double click on it, and you can arrange the position in depth. For example, in this case, I would like to select front, and thickness can be stayed as 20 millimeters. Okay. You can also set this alignment with Ctrl and W buttons on your keyboard. It's a shortcut for the position of depth command. Okay, let's turn back to our section view. So in this view, I'm gonna roll back the plate definition. Okay, you can use Ctrl and Z command for this. At this time, the second insertion, we will talk about the second insertion method. For this method, I will use the points. So for these intersections, I will create points here, and we can also create the parallel of them. So to do this, we have a create parallel points command. You can right click and specify the distance. For example, in this case, we can type in 700 millimeter. Okay. Again, I will draw line between those 2 points, and the parallel points were generated here. Now we have all corners of this plate, so I can quickly draw this via these points here. Again, with Ctrl W button, you can change the alignment of it. So the next thing that I want to talk about is bolts. So for the bolts, let's select the section view again. And we have a create bolt group command here. After the selection of this, I need to select first plate, then the column flange. If there would be another plate, we could also select this plate. Okay, then right click. Now I will draw the X direction of the bolts. For example, we can use this line for it. Now, as you see, our bolts seems in wireframe mode, and they are not valid here. So because of the undefined position, so let's place them in a proper positions, and it will seem as solid. So when you double click on it, you can get into the bolt properties. So you can add washers, nuts here, and you can change the positions. So in the X position, for example, 37.5 and 75 millimeters, I'm typing in bolt spacings here. For example, 3 multiply 100 millimeter. It means that we have 3 times 100 millimeter spacing on the Y direction, and 2 multiply 145. So let's select the apply button and OK. As you see in 3D view, our bolt group has been generated. Okay, I think there's a question here. Okay. So again, I will minimize it. So after the bolt group, we need to create our cuts. So as you see, the beam and this column is colliding here. So we need to add a cut object. There are several cut objects over here, as you see, polygon cuts. Cut this with that boundary, or 2D fitting macro here. If you ask me, the easiest way to create a macro is 2D fitting macro. So you can simply select the member and define the cut plane, okay, on the edge of the end plate here, and the cut has been generated. Okay, for example, in this 3D view, if we want to return back to the global coordinate system, we can just click to the global button. Now we will add our welds for the intersecting edge between beam and end plate here. Okay, for this purpose, I will create again one more section. Okay, or we can do this also in 3D view. So we have two weld commands here, as you see. So I'm gonna select the general purpose weld, which means create weld command. First, we can select the edge of the beam web here, for example. Let's select it, and the main plate. With the Alt-D button on your keyboard, you can quickly review that your weld is defined properly or not. For example, as we talked before, the magenta color was a sign of the a sign that the weld has been created and annotated properly. So let's double click on it. You can change the weld material here, play with the types as you see in here, and you can also change the operation location. For example, it might be on site or on the workshop, or we can change the weld type. So in this case, I want all around. So the weld will be created all around the profile with this selection. Okay. So the next thing that I want to talk about is hunch plate. So I will create a triangular plate on the bottom of center line on the beam flange. So for this purpose, I will create a section which cuts from the center line on the beam. Again, views, create view by 2 points. Okay. So column and beams, column and beam center line are the same. So I will draw on the column here. Okay. Now for the triangular plate, we have 2 points: end plate corner and the intersection of the beam and end plate here. And third one, the third point will be on the beam flange somewhere here. But to create a proper point here, I need to move my work plane with the aligned way, with the angular way. So to create this, select the member, right click, and set work plane. I'm going to select by 3 points. So first we can select the this intersection point, you can press to the control button to snap the node on the flange, okay? And the third point will be perpendicular to the second one, okay? Now we can create a point on the flange of the beam. So I will click to the point command here, and I'm going to create a point on this intersection. Then we can copy this point to the 50 centimeter away, which is positioned on the flange. For this purpose, we can use copy linear command. Okay. So we can reset it, and it will be on Y direction. So what I told before, the X direction shows with the red arrow here. So we can type in, for example, 500 millimeter and click to the copy button. And as you see, the point has been generated here. Now we can quickly create a triangular plate. And in 3D view, you will be able to see this hunch plate here. Of course, there will be a hunch flange, so I would like to move this corner up for like 30 millimeter. So first we can select the Alt button on our keyboard and select the corner. Then you can select right click. We have a move special command, but the important thing is, again, our coordinate system has stayed in the local work plane. So I would like to return back to the global coordinate system with this button. Again, move special linear way. So I would like to move this corner 30 millimeter upward here. Okay. So now we can define the flange of the hunch plate. For this, we have a sectional plate macro over here. We can select this macro and select the triangular plate, and we can draw the direction of the sectional plate as you see. So I would like to double click on it, and we can change the width. For example, 150 millimeter might be suitable for here, and the thickness can be 15 millimeter here. Okay, let's apply and click to the OK button. And I would like to say that this macro creates its weld automatically here. Now I would like to show how we create chamfers on the plates. So let's isolate this member with the show only selected button. So again, I will press to the Alt button on my keyboard, and for multi-selection you can press to the control button at the same time here and double click on it. So as a chamfer type, we can select the radius as type 2. I generally use this chamfer type, and the radius can be, for example, 30 millimeter here. Again, we can show all members here. Now I need to also add welds for the between end plate and the triangular plate here, and also with the lower flange of the beam and this triangular plate. So for this purpose, again, I will do the same stuff that I've done before. Weld command, select the edge, then main member. Again, select the edge, then main member here. So as you see, all the welds are shown in magenta color, so I can continue. It means that welds have been created properly. So let's click to the weld, and I would like to create this weld type as front and back. Okay, so with Alt D button, you will see that the welds created for the front and back sides of the triangular plate. Okay, let's add our stiffeners. For this purpose, we have a stiffeners macros over here. So I'm going to select the stiffener macro and select the object. Then we can specify the position of this stiffener here. For example, for the here, and I will add 2 more stiffeners for the hunch connection. Now we have created the hunch connection in our model manually. So there are some selectability and visibility settings here. You can turn off this cut command in the view, or you can activate it again. First, actually, before we create the manual macro, we need to specify the work plane to the point. So for this purpose, I'm going to select work plane to point. Okay, then we can specify a point on the middle of the flange here. Okay. This is important before the creation of manual macro. Okay, then we can select all components of this connection and select the manual macro icon here. As you see, when you hover over, you can see the tips about its usage. So let's click on it. Again, for example, we can type a name here, hunch connection for IPE 300. We can give a name here. So as a type, I will select a collision, because in this case, when the column and beam members are colliding, this macro will be applied. Okay. So let's select the collision. If you want to see the requirements of this type, you can just select this question mark button and review these requirements here. So let's create a new group. I can also add this connection to the another groups, but I want to create a new group here. We can retrieve as created members. Click this button here and select main members. In this case, I need to select first beam as a main member, then column. In macro creation, we do the opposite. So we just select the main member, which is column, and then beam. So it's a little bit different with the macro creation. And let's save and OK button to close the property window. Okay, I will now I'm going to copy this connection to the opposite side here. Okay. Again, I need to specify the work plane here. So set work plane to point, and I will do the same as I did in the previous one. Okay. Now we can select the manual macro again, and I'm going to select the created connection previously here, and we can create a connection. Sorry again. Maybe we can do again, create connection. So I have similar one. We can do the same actually for beam and column here, and we can specify the center point here. So as you see, we have created the hinge connection from the manual macro. The next thing that I want to talk about are circular base plates. So to create a circular base plate, first I would like to hide the pedestal here. Okay, we can hide the pedestal with hide selected command. Then we have an end plate macro over here. You can select it. Then I'm going to select the column and show the center of the column bottom point here. To get in the macro, you can press to the M button and enter button. Okay. Now I would like to type in the extension length, for example, 100 millimeter. Okay, and I would like to transform this plate to the circular plate. Also, thickness might be 20 millimeter and material can be selected here. Okay, the next thing that I want to show how we create the holes. So to do this, again, I'm going to select the create bolt group connection, bolt group macro here. We can select the plate, then right click. Now I need to specify the X direction of the bolt group. So I can use wireframe for this. Okay. So now I'm going to double click on the bolts. We can transform this bolt to the hole here. And diameter, let's add 2 millimeters tolerance, and diameter might be 22 millimeter. Okay. In the position tab, we can create this holes on the circular path. So I would like to create this holes to the circular, to convert this to the circular path. And the radius can be 160 millimeter. Let's type in 8 for the number of the holes. Okay, let's apply and click to the OK button. So after this, we can place the anchors. Okay, so to do this, select the anchor button here, then right click in the empty space. Sorry. And select the plate here. So the anchor bolts will be created for the each hole on the base plate. So let's remove the second nut of these anchors. Okay. For this purpose, I would like to get into macro properties, M and enter button. So in the geometry tab, we can specify 0 value for the second nut. Then this nut will be removed from the view. Again, I would like to save this connection as the manual macro. Okay. For this purpose, I will select all connection components here, and again, I would like to select manual macro icon. This time we can type in, for example, circular base plate here, and type this time can be in the global position here. Okay, let's create a new group and retrieve as created members. So as the main member, I'm going to select bottom node of this column. So I can use wireframe view for this purpose here. Okay. And we can save and OK button to close this window. Again, I'm going to return to the realistic view here. So let's copy this macro to the similar place. Okay. Again, I'm going to use manual macro over here. Select the circular base plate and create a connection. Okay. So again, Alt D button. You can select the center of the column. Sorry, let's do this again. Okay, so let's do this again. Okay, Alt D. Okay, so as you see, the circular base plate has been generated here. We have also a notch macro here. We can use notch macro for this kind of connections. So to use this, we have a notch macro over here. So we can select this and select the main member, and you can specify the cut edge for the selected member. Now we already created a hunch connection and circular base plate here. Okay.